Hi, I am Tor Hansen, the CEO of Ceetron. In this short video, I will show you how to get started with our new CAE post-processing tool, Ceetron Analyzer. First, we will take a high-level overview of the user interface. At the top, we have the menus. Underneath the menus, we have the icon bar with the most frequently used features: draw styles, animation control, animations, and such. Underneath there, to the left, we have the workspace, which is one of the most important parts of the user interface. And then on the right-hand side, we have the 3D window, where all the models and results will be presented. And we do that by going to the File, Open File, and here I have a forging model, and I simply click Open to that. It's a fairly big model, and here we are. Model. You use the mouse, the left, middle and the right buttons in combination to navigate the model. In the workspace at the top we do have the View menu, which controls the global setting of the 3D view, such as the color of the background. We have the state info, navigation cube and other global attributes. Underneath the view we have the parts, which is the geometry itself, which in this case consists of 3 parts. It's a billet, and it's an upper and a lower die of this forging process. We can see the billet in the middle here, and the upper and the lower die. The parts menu can be expanded and collapsed. Underneath the parts we have the results. This is where we can see all the results that's available in this particular simulation database. Results are organized in the scalar results, and there are the vector results, then there are the displacements, and in addition to that there is a time history in this particular simulation. To load a result, you simply click on the result you would like to present on the model. In this case I can try the temperature, and we can see that the billet got the temperature. The upper and the lower die is gray, which means that there are no defined results for this particular model. I will turn the visibility of the upper die off, and I select it and I right click and I say hide the selected parts. So right clicking is a very important feature of the way you navigate with the analyzer. To select a second result, we simply go, for instance, to the vector and say that we would like to show the first principal stress. Activate that, and then it's loaded onto the model. As you can see, the vector result looks pretty chaotic. I will zoom in a little bit. And now I will show you how to control the settings of a specific result. We go to the result, we identify it, and then we can, for instance, apply a scale factor, which is an attribute of that particular result, and we can see that the errors are becoming smaller, scaling smaller, and it becomes more sort of understandable how this principal field is looking. I now have 2 results available, and I can go to the global view of the results by clicking on the results item in the workspace, and here I can see that I have the first principal set, and I can turn it off by simply clicking there. In the scalar I still have the temperature, which I can turn on, off and on again. There is also the time history, in which you can either select single step, or, as I will show you in a little while, how you can set up a complete animation to play through the time history. For doing advanced result interpretation, we have underneath the results item the cutting planes, isosurfaces, isovolumes, and particle traces. These are features that will give you a deeper insight into your results. I'll demonstrate the principle of how them work by using the cutting planes. So I click on the plus sign here, and there is a cut plane enabled in the model. Now I can see, selecting the cut plane, I can see the settings which applies to that specific cut plane. And one of the characteristics of the cut plane is of course the orientation of the normal vector to the plane, and also the positioning of the plane, which is manipulating using a slider, or we can change the orientation, or we can even have an arbitrary point to give the positioning of the plane in the 3D space. I remove the plane again by clicking on the minus sign, and we are back to sort of full model visualization again. The other isosurfaces, isovolumes works exactly in the same way. Particle traces is typically applied to flow model to study the internal flow of a CFD computation. This will not be demonstrated in this video. Underneath here we have the animation control. To set up an animation, I right-click on the animations item and I say add a transient animation. So there could be sort of two options, either a transient or a mode shape animation. Now this is only a transient animation that I will be setting up. And once I select that, I will have the states from 0 until the end of the state, and there's also a skip by factor. These are default set to the full animation with no skip factor. So all I have to do then is to set up the animation. And we can see the results are loaded in and the animation are set up, and now the animation runs. I can also control the speed of the animation by using this walking man with a stick symbol or the running man to increase or decrease the speed of the animation. Underneath the animations menu there is the element sets menu. This is also grouping of elements that typically can be different from the parts group. On the 2D plot, next thing I'd like to show is how to create a 2D plot. Unlike most of the other items in the workspace, we cannot create the plot from within the workspace. The way we are creating a plot is that we first have to select points from which we would like to create the plot. And then there is a little tip or trick. If I click in the icon bar and I right click, I can see the various window elements in the user interface that I can turn on and off, and the selection pane is turned off. In my case, I will activate it now, and I can see that now on the left hand side where the workspace was. The workspace was then pushed a little bit down. So what I will do now, I will go into multi-select mode, and up here I can decide which sort of items I would like to select, either an object or a node or an element or element node or even a coordinate. So I will multi-select a couple of nodes that I will use for my length plot, which I will create here now. So now I have a list of 6 nodes which is selected, and I right click in the window and I say new length plot with all these items in it. And here I got the length plot, and I can move this window around. It's overlaid on the 3D model, and you can see the transparency in the back there. It's also possible to control the settings of the plot by the same principle as here. We click on the plot and then we have control over the settings of the plot, namings, axis, grid, etc., etc. Final thing I'd like to show from the workspace is the annotations. So I remove the plot. I can also remove the element set. I can go to the annotation. I will also clear the node selections. To create the annotation, we could either right-click in the workspace, or we can use the icon bar. At the top, I will use the icon bar. I will create a text annotation. I position it by using the mouse, and then I can give it a name, high temperature, for instance. So that's a annotation which is then positioned onto the 3D model. I can do another annotation, which is an angle. I can do that here. I'll rotate my model so I can see better the angle annotation. And we can see that this was an angle of 80 degrees, roughly. And again, I can give it a name. It's like that. The final thing I would like to show is how to use what we call the web sharing, the Ceetron Cloud, to share this model with peers, colleagues, or others. Let me just clean up a little bit in my model, like this. And I will also initiate a cutting plane just to show the power of the 3D viewing. So let's assume that this is the model that I would like to share with someone. Ceetron Analyzer is connected directly to Ceetron's web sharing service, Ceetron Cloud. You have to, first time you use the Ceetron Cloud, you will be prompted to create a user there. And after that, your simulation models will be stored whenever you want to share them. They will be stored on the Ceetron Cloud. Up here, I can go in and see on my area, storage area on the cloud, models that I have created and shared, or created or prepared for sharing, I should rather say. So in my models folder, I have all the models that I have shared, and here I can view the model, or I can even launch it in a cloud version of Ceetron Analyzer. I will show that very, very briefly. I can present the models in here in different ways, a list model, or a sort of a list with icons, or a grid mode. It's different ways of presenting them. This is quite a nice mode to show. So I will be returning back to Analyzer, and I will then see the two icons to the left in the user interface, send to cloud and send full model to the cloud. These two, by clicking these buttons, I will send the model directly to the cloud by one click only. The difference between these two, full model and only sort of the surface model, is that the full model contains all the finite element data, and you can then use the model for further post-processing on the cloud if you wish. So I click the full model, and the model will now be sent to the cloud. As this is a pretty big model, I will settle for only sending the surface model to the cloud. I click the icon, and as this is a big model, even the surface model will take some time to upload to the cloud. But on a wireless network, we are still moving with very high speed. So now the model is stored on the cloud, and I will get the confirmation. Here it is, and this model is now stored on the cloud. I can either view it directly in the browser, clicking on this link. So this is how the model looks when it's stored on the Ceetron cloud. I can play the animation and it will look exactly as it would. I see there is a bug there with a cut plane, but that will be fixed. If I go to my cloud directory, I will see that in my models, this particular model is now in place. Here I can see I have a lot test models that I have. This one is the latest one. So I will go in here. I will do a grid view. This one. Here it is. Pretty nice. I go back and I will finally show you one little thing that I can do. I mentioned this about editing the file. I'll pull the we can see here that we have two options, either to view the model or to analyze the model. Viewing the model would be exactly what I did. Analyzing the model would be launching this particular model in Ceetron Analyzer for Cloud, which means that I can, if I have had the full model, I can continue with my post-processing. Now in this preview version, I start out from scratch, not with the correct attribute sets, but that's to be implemented before release. But I see on the results pane or the workspace, it looks very much the same as the desktop version of the analyzer. If I want to put on the results, I simply add the result. This is a scalar. We didn't have a vector or a displacement with us. So in Analyzer for Cloud, I could continue the post-processing, for instance, creating a 2D plot. Slightly different user interface for now that will be harmonized with the desktop version. Click on the node, and this is a time history plot of that temperature for that particular node. So that concludes this demonstration. Introduction to Ceetron Analyzer. Should you need support, please send an email to support@ceetron.com. Thank you for listening.